Good morning, everyone. Hope I'm audible and my screen is also visible. Great. So, great. Thank you. So, before going ahead with this session, I would again introduce me, uh, myself, Rajmohan Bharti, and I have around 2 decades of experience in IT infrastructure managed services, and that means I have experience in servers, various technologies, virtualization, network for security, cloud operations, and so on. And I would also request to know every one of you to just give an just introduction about yourself, uh, your name, and what exactly your job profile, and what is your expectation from this course. I would start from Madan Mohan.
Hello.
Hi.
Hi. This is Madan, and I'm working as a Unix administrator.
Okay.
Okay.
And what is your expectations, and how many years of experience do you have?
I have 5 years of experience in Unix administration. I'm lagging some network related issues, so I want to learn this Cisco certified networking course.
Okay. Okay. Great. Thanks, Manu. Desmond.
Hi. Yeah, I kind of started CCNA before now,
Okay.
but I didn't finish up, so I just have a little basic knowledge. So I just want to see how this program can give me the needed hands-on, and I should be able to use it to get a job, right? I also
Yeah.
did AWS program before now. I worked
Okay.
with it for 6 months. It was a
Okay.
contract. It ended. So I'm really hopeful that
Uh. Okay. What's your current profile? Can you just what's very few? Desmond. Your current
yeah,
profile?
current like working. No, for now I'm not working.
Okay. 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 Shashi.
Yeah, good morning, sir. I'm Shashi from Pune, India, and I'm working as a TM in one of the advertising company.
Okay.
And total, I have 15 years of experience.
Hmm.
And for, I just wanted to know about the CCNA and this networking all concept because like our company is going to be migrated to AWS and all the cloud platform.
Okay.
That's
Great.
why.
Great. Great. Thanks, Shashi. Tani.
Yeah, good evening, everyone. I am in telecoms and I want to change careers and I'm looking at getting into IT and I want to start with networking and database administration and CCNAs. It seems like the way to go for a start.
Okay. Yes. Great. Great, Tani. Hari. Hari. Okay. Karthik. Hi, Karthik. Okay. Kamesh. Kamesh, hi Kamesh, can you just introduce yourself? Kamesh. Rest of the people like Mahesh and Olumide, can you just introduce yourself one by one? Mahesh and
Hi,
Olumide.
good morning.
Hi, hi Mahesh.
Um, I'm Mahesh, but I have completed MCA now, so I'm
Okay,
pursuing the
okay, great.
that's why I'm interested in CCNA.
Okay, great. Olumide, Olumide. Okay. Uh, Thanks everyone for introducing yourself. It's a pleasure to have you all on board on this session. Okay, so let's start. My screen is visible to you all, right? Okay. So welcome to the CCNA certification course, and I would also request to know, please have a key attention while we do all those sessions. If you have any queries, you can put your queries on your chat box, and or you can raise your hand while the presentation is going on, so that I can address the query at the same time. Or once the session is complete, we can have a quick Q&A session for 5 to 6 minutes, and you can ask questions at that time also. Okay. So this session this course is for 36 days, and it starts every day 6:30 a.m. And about this session, one more thing which is very important, we are going to host these these sessions in YouTube for your future reference. But the session only first 2 days sessions will be recorded, and that will be hosted on YouTube. And I would also request you to join the WhatsApp community, and those links will be available in those WhatsApp community. You can share about how the learning is going on and how um, and of course also those sessions are actually, you can keep it for future references you, and post those two recordings. The third session will be free to attend, and once these three sessions are completed, from fourth session onwards, you will only, the paid candidates would be get the Zoom link to attend the class. So the first three sessions are free, and that also the first two sessions will be recorded, and that would be available in YouTube, and those links will be shared in the WhatsApp community. And I would request all of you to join that WhatsApp community, so that you will get access to those links. Okay. And if anything you want, any support you want, you can write email to support@logiclabs.com. And also, once you are enrolled or onboarded on our platform, you have an LMS portal through which you can access all your recordings and notes and everything. And as you can see, the support team is available from Monday to Saturday, 9 a.m. to 7 p.m. Okay, so I would urge and request all of you to please join those WhatsApp community. That will be really helpful. And also, if you have any queries, you can call on these numbers regarding to course, or you want any support with regards to LMS. You can call these numbers, and you can email those on support@logiclabstech.com. Okay, thank you. So let's move ahead. So we also request to just know, register yourself in Logic Labs, and you can join our YouTube, Facebook, and know You can go through those the multiple demonstrations which has been had in the previous or the current session which is happening, and have good learning. Okay, so as I said, this course is basically for CCNA official certification curriculum. But before we go ahead and start those official curriculum, I just want to give an heads up or kind of a refresher session for the basics. Uh, some of you might have a repetitive session, but I think I just want to address everyone so that all of our students are in the same page. So we will have a quick review of the last session, what we had, and then we will proceed for today's session. Okay. So again, these are the topics which would be covered, which covered yesterday, and couple of them will be covered today. And let's go ahead. So we talked about network fundamentals. So what is exactly a network? What is exactly a network? A network, as you know, as the name states, it's it's a communication between a connection between two or more computing devices to share your data and to communicate with each other. And why it is important? Because in today's era, without network nothing is possible. Your smartphones, your wireless laptops, everything is hooked onto a network, and without network no communication is possible in current current scenario. So it's very key to understand how network works. Now, talking about topologies, this is a basic concept of network, how the network is physically connected, how the devices are physically connected. And in this scenario, we have six type of topology, or six ways of six designs of how the computing devices can be connected. The first one is bus. It's the older one, oldest of all, and now we are not using this technology as of now. This is a one way. All those computing devices or computers are connected to an hub, or they are connected to an BNC cable, or T connectors and all. So they are all connected to a single media. If any disconnection between any of the 2 points, the entire communication of the network goes down, and that's a disadvantage of this. And also in bus, whenever suppose an A system wants to communicate suppose this A system wants to communicate to B, let's say A and wants to communicate B. In that case, the A system sends a message to the device, to the hub. The hub will broadcast the message to everyone, and whoever is the recipient will respond back accordingly. And each and every time the same process is repeated for the communication. And also there's a chances of collision when multiple computing devices try to communicate with each other, and there are chances of collision also. So this is the oldest of all. Then we have a ring where all the devices are connected to each other. It's like a circle where and again it can be both unidirection and bidirection because it's a circle. And mostly rings work in a for example, ring is a very older technology, but still uh, we don't use it for a LAN kind of segment, but rings are used in a very huge like for example, you have a metropolitan city and you want to lay a big cable around your cities, and that can be a kind of a ring, so where you can connect end to end, and you have multiple paths. If one path gets disconnected, there's another path to communicate with the rest of the locations. So that's one way where we use ring, but that's not exactly we don't use it on LAN or internal office designing. Okay, mesh is like each devices are connected to all the devices are connected to each other, and this is only useful for very huge networks. It has this is very expensive, and I can say that for internet is a huge mesh what we use today. All the entirely global is global networks are connected with each other, and so that's kind of a mesh. Star is star topology is the very common one which we use in our day-to-day offices. We have a common distribution box which is connected to all the computing devices, and that distribution box, what we call it as a switch, that's not the on off switch, that term is switch, and it's usually is a switching technology, so it kind of communicates between different devices, and it precisely communicates from source to destination. It doesn't broadcast the that request to all the users. So and switches are intelligent. So usually in our office we use star. And then tree is, I can say, it's where the devices are connected in a hierarchical structure, and that's called tree topology. And mesh is kind of combination of two topologies, where you can, let's say, you can use star and tree. You want to use both, then that is called as hybrid topology. So these are nothing but the way you uh, connect, where you design your physical network. And in our day-to-day life, where a normal network addresses, so we can see only star, or maximum we can see tree. We will have very less scenarios where you can see hybrid or mesh or ring or bus in today's era. So mostly we'll be seeing star and tree. Okay. Okay, so covering about the devices, what are the common devices which were used in network, in a network infrastructure? So hub is a very outdated device, as it was a device which used to connect various devices in your local network, but as it is it's an one way at it's kind of part of bus topology. It communicates in only one direction, and it has all the disadvantages which we covered in the previous slide about bus topology. So now we don't use hub. Routers are basically the devices, key devices, which is used for no communicating between two or more networks, and routers are very key. And then we have switches. Switches is again a very common equipment or a device which can be seen in a lot of offices. This is kind of a distribution box which connects all of your devices, like your computers, servers, printers. All those devices are hooked to this particular device, what we call it switch. And then we have bridge, and bridge is kind of a device which is, or you can say, kind of a modem, where you have two different, one interface would be probably connected to your LAN, and the other interface would be a kind of an no modem, where you have dialers to connect to internet. This is a very old device. I mean, nowadays we don't use bridges or repeaters, so these are outdated. So in this image, you can say hub, repeater, and bridges, or almost we don't use it nowadays. But for your knowledge sake, it has been depicted here. And yesterday we had a bit discussion about gateway. So gateway devices, uh, there are a lot of devices which are act as a gateway devices, or act as a gateway. So gateway is like a door of your house. It's where the traffic comes in your network and goes out. So that device can be a router, that device can be a firewall, and that device can be any gateway appliances. So it is purely depending on what kind of network infrastructure we are going to design. So gateway is a very common term. It's like a door at your home. So when you open the door, the guest comes in, and when the door is locked, no one comes in, and if someone is come, you just knocks the door to get in. In the similar way, gateway or or a firewall where we uh, if the traffic is allowed, then only the traffic will come inside, else the traffic will be dropped at the gateway level itself. So this is a, a bit overview of network devices. And again, we'll just have a quick comparison on LAN, WAN, and MAN. So LAN is local area network. We discussed in detail yesterday. So it is kind of a private network where all your devices are connected in a single. It's in a uh, single premises, or you can say, or even in a multiple premises, then within a range of 1 kilometer, all your blocks or your offices are connected within that using fiber optic or probably using Wi-Fi. So that is called LAN. And MAN is within a span of probably if you have a city where you have around 10 or 15 offices and you want to connect those offices, and then that is called a MAN. And it can be public and private, because the ownership of that particular network can be associated with a private organization, like any company or any manufacturing company or anything. Or also it can be an public, let's say like a service provider who has multiple offices across your city to provide services to you. So that's kind of an public. Now, WAN is a huge network. Internet is in WAN, where the entire entire globe is connected. So you can the network which is connecting our entire all those continent can be that huge, can be taken as a WAN, wide area network. So uh, so the basic thing is the WAN can be, again, WAN can be public. When we talk about global connectivity, all the entire globe is connected, and that what we call it is internet, a huge network, and that is public. Again, in WAN, there might be an organization where we have uh, offices in like Australia. There's a office in Australia. There's office in India. There's office in US, and they have a very huge global presence. And they were all those different networks are connected uh, via VPN or whatever methodology. Then that is also, we call it as a WAN, because it's a huge network. It has a lot of cost involved to connect those huge networks. So that's the difference between LAN, MAN, and WAN. And if you have any doubt, you can and drop your questions on the chat box as of now, or raise your hand. Thank you. So one more type of network which we are very we have very common in our home or in our day-to-day environment is wireless. So so wireless is kind of so basically there are two mediums in which the data communication happens in a network. One is wired, where you have wired cables are connected to your desktop, laptop, or whatever from the distribution box. Another one is something called as wireless, where you have wireless adapters which are connected to your laptops or your mobile phones or your systems. And there is a wireless router which communicates with your device in a specific frequency. So there are two frequency in which nowadays, in fact now three frequencies. So it's 2.4, 5, and 6 gigahertz. And so these are the speeds in which the devices communicate with each other. In wired, there is no specific um, mm, security protocol or security, we can say security parameter, which has been incorporated while you have a LAN, like local area network. But in wireless, of course, there is a something we call it as an web. So those are basically to authenticate, because that's authenticate to your network. And we use credentials, we use OTPs. There are a lot of mechanism to do that. And again, I will tell you, Wi-Fi doesn't mean internet. There's some misperception that when we talk about Wi-Fi, people have a misperception that Wi-Fi means internet. So it doesn't work that way. So there might be a network where you have wireless and then it's wireless LAN, because you are connected in a closed private environment, and the medium is not wired, it is wireless. So it is not mandatory that even if you connect via Wi-Fi, it is you will have an internet connection. Unless until you have an internet connection, there are only two mechanisms to connect to a network. One is wired and another one is wireless. So Wi-Fi doesn't mean internet. So that I just want to clear it up. So so in your home, if you connect to a wireless router, uh, so it actually doesn't mean that you are connecting to your internet. Let's say you are all of your devices, smart devices are connected to hooked onto a wireless router, and the internet connectivity is not there. So it doesn't mean that all these devices cannot communicate with each other. Of course, they can communicate with each other. They can transfer files. The only thing which they cannot do is they can't access the uh, public network, or they can't access the websites which is posted in internet on a global network. Rest, if anything which is available within that LAN is accessible via wireless or wired, either way. So I just want to make sure that we are clear about Wi-Fi. So wireless, that is actually a wireless LAN. The actual term is wireless LAN, where all of your wireless devices are hooked onto an access point or to an router, wireless router. Okay. Is there any doubt here, like about wireless LAN or LAN or Wi-Fi means usually people talk about internet. So any doubt so far? Yeah, yeah, Desmond.
So when you say router, wireless router, is it the same thing as like a switch?
Pardon me. Can you just repeat? Your voice is
Yeah.
very low.
Okay, sorry. When you say router, is it the
Okay.
same thing like a switch?
It is. See, when we talk about router, wireless router, right, Desmond?
Yeah.
Okay, so wireless router has that device has two parts, or I can say even three parts. So usually a wireless router has a switch, a four-port switch, where you can connect your devices in your LAN, local area network. At the same time, you can hook wireless devices, because those wireless routers have antennas. So their wireless devices also can be connected to wireless routers. That's the first. Second thing, and the third thing is that particular device has a routing capability, means that particular device can connect to another network. Okay. Here we mean by internet. So so to connect to external world, to connect to a public network, we use the router's third capability, that is called a router, which in turn gets connected to our ISP, and from ISP we are able to access internet. So a device which is connected, which is in your home or in a consumer, what we use in day to day, has three capabilities. That's it. One, it has a switch, which a four-port switch or maybe a eight-port. It depends on what kind of Wi-Fi wireless router you use. So usually it have four ports. That four ports is dedicated for your wired devices can be connected, and there would be one port which is as an incoming port from your external world, and you can see that is written as an internet, or it will be written as a WAN, wide area network, where your external connection gets terminated. And then there are two or more antennas which are basically a via medium to connect all your wireless devices. It may be a smartphone, a smart TV, or maybe your laptop. So all those are part of local area network. Eventually, because of the cables, with external cable or service provider has connected that WAN port, so that you are able to access this public internet. So that's how router works. A wireless router works. Am I clear? or you have fill in doubts?
Yeah, that's fine.
Okay, great, great. Thank you. Anyone else? Anything else? Shall we proceed? Okay, I'll take the silence as yes, and I'll proceed. Thank you. So yesterday we started with the very basic uh, standard about network communication is OSI layer. So this open standard is basically is a standard which is set for any type of communication between two devices, and this is a very basic uh, uh, standard which everyone should remember while we design any kind of network solutions. So what device will be placed at which layer? What are all the aspects of the each layer? What is the functionality of each layer, and how the data travels from one layer to other layer? So we should be able to understand that basic sense of it. So this diagram we'll see later. Let's go to the theory part. So when we talk about network communication, we can take this as we can take an analogy of post office. So when we talk about a post office, there are a lot of uh, people who comes in our mind when we talk about post office, a place where a lot of letters come, per person who delivers letters to your home, and so this is an entire workflow for post office works. So for example, I write a letter to my brother. So now the days of letters are gone, I understand, but to make it easy, I write a letter to my brother, and so so what I write is, I write the from where I'm writing this letter, the address, for that, for the postal department to know that this is from Pune, India, and the letter is destinated to Bangalore, Karnataka. To my brother, the content of the letter is secret. That is between me and my brother. But the exposed one is the source address and the destination address. So here, if you take this letter, there are certain parameters we will compare. Okay, so the sender is the device from where the request is initiated, or the communication is initiated. That's first thing. Second thing is the data, which I told it's secret. It's between me and my brother. So it's simply the data has to be visible between only the source and the destination. And third is the addressing part, where where the source address and destination address, which is visible to uh, to the postman, or here you can say to the device, which is going to communicate between the source computing device and the designated device. Okay. Now here there are two items which are, or two components in an addressing. When we talk about addressing, one is IP address and another one is MAC address. So I can compare that with our day-to-day life. So IP address is something like our home address. For example, today I am staying in an apartment. Tomorrow I will be staying in a different apartment once my lease is over. So it would change. But talking about MAC address, that is like my name, or that is like we have something called Aadhaar card or SSN in America, like say let's say a social security number. So that is like something which is very personal to me, and it cannot be changed forever. So in the similar way, in network, every device which is communicating to other device, that particular device has a physical address. So that we call it as a MAC address, and that is universally unique to each and every device which is communicating to each other. So for example, in our laptop, there's a network adapter or network card to which we connect your network cable. So that card which is present in your laptop has a physical address, because that's a device is going to communicate to the next to the other device. Now here the MAC address of the source device, the MAC address of the destination device, the IP address of the source device, and the IP address of the destination device are the key addressings for a communication between two devices. Now, talking about this communication, whenever a requester initiates an communication for a designated device, then the switch or a middleman or the distribution box picks up the data, and then he looks in a table where there's a table is created where the MAC address are mapped to a port numbers. Let's say my laptop cable is connected to the first port of the destination, and the designated device is connected on the fourth port. So uh, once the request reaches the switch understand that this particular request is for the port number 4, because it opens the packet, the data, it's open the network packet, but doesn't open the data. It opens only it just looks for the source address and the destination address, and it verifies in the MAC table that this data is coming from port 1, and that's the MAC address, and the designated MAC address is at port 4. So I should route the traffic to port 4. So that's how the communication happens between two computing devices. Now here, the MAC address and IP address are very key when we talk about any network communication. Now here, so we talk about when we talk about an envelope or an inline letter or maybe a postcard or whatever it may be. So here, the key things as we discussed: sender's address, receiver's address, that's IP address and MAC address, and that is required. And also the post office or the postal service through which the data will be, or the letter would be traveled to the designated network. So we should know what is the shortest route to for example, from from Pune to Bangalore, what is the shortest route to deliver the letter? So there are various biomedias. There are medias like you can send it by flight, you can send it by trucks, you can send it by bus. So there are various way to deliver it, but we will try to see what is the best way or shortest way to deliver the letter to my brother. In the similar way, in our computing world and in network infrastructure, when we talk about two devices to to communicate, always the device which is like maybe a switch or a router will always find the shortest way to reach that destination, and that responsibility it's belong to the switch and the router. And again, as I tell, the via media, what we talked about, like trucks, planes, buses, it's in our network communication, we call it as an protocol. How the data is transmitted, the transfer protocols, it may be TCP IP, or it may be any other protocol we might be used to communicate between two devices. So that's how we compare postal service with our no net communication of network between two devices. Okay, you have any doubt till here? Any doubt, please, before we go ahead? Please, you can raise your hand or you can drop your questions in the chat. I'll wait for a while. Okay, I'll take the silence as no, and I'll proceed. So talking about the OSI layers, so there are 7 layers: physical layer, data link layer, network layer, transport layer, uh, then your session layer, presentation layer, and application layer. So these are the layers where these are 7 layers which are very key. Talking about physical layer, it's actually the cables, Ethernet cards, and all those stuffs comes under physical layer. Your network card, so all those comes under connectors, and all those comes under a physical layer, because that's part of a physical device which is used for communication. Now, data link layer ensures that uh, data link layer in data link layer we talk about MAC address, which is very key, and also we also make sure the data which is sent to the next layer it is error free. So these are the things which are verified in data link layer, and make sure the the packet is intact without any error, which has source address, destination address. Here the IP address is not no, considered. In data link layer only MAC address are actually are considered, or are opened and checked whether what is the source address, what is the destination MAC address, and is the traffic, is the packet which is no initiated from the source, is it having any error, or it's error free. Then only that particular layer communicates with the next layer. So in the next layer, it comes the IP address, where the IP address, let's say source IP address and destination IP addresses are no reviewed, and here we are seeing what is the best way to deliver the data from one device to other device. And that's why the layer 3 is very key in network. Layer 3, where the routing comes, all the routing means what is the shortest path to reach from a location to another, and that's all decision taken in a network layer. And in layer 2, as I discussed, the switch with the distribution box, where I taught you about the MAC address and the forwarding table and all, that comes under data link layer. In the network layer, we talk about IP address, and we talk about routing. We will, whenever we when we will covering all those devices, no we will also link those devices with these layers in detail when we get into depth. Okay, this is just an overview how those layers work. And transport layer actually ensures that you have a reliable transfer from the source to the destination. So there are two types of transfer usually in network. We have something called as TCP and something called as UDP. TCP is kind of an um, foolproof communication between a source and a destination, uh, where we get an acknowledgement from the destination that the data is received, and everything is fine. And in UDP you don't have that. So usually the data is sent. There's no acknowledgement that whether you have no UDP doesn't wait for the acknowledgement from the destination whether the data is gone error free or not. So that's how the TCP and UDP. Like again, in session layer, so we have uh, session layers creates in session between both the devices, or no both endpoints, and it kind of no the session is created for the entire one communication. Let's say I have sent a message from A computer to an B computer. So there will be a session will be created so that the communication is completely the communication between source computer to the destination computer is actually fully completed. So session layer takes care of the session, and presentation layer is kind of a data conversion, data format conversion, where for example I know I know what is an email. I know what is an FTP. I know how the applications works at high level because I understand only that because that's English. But presentation layer is kind of a layer where the data is no converted into a format where the data can be transmitted via network. And also in such a in presentation layer, if there is any additional encryptions or data compression has to be done, that is taken in the presentation, that is taken care in the presentation layer. The last layer is application layer, where we interact, whereas we users we interact. So It may be an HTTP request, it can be an email, it can be anything, it can be in chat, internal chat between within your organization. So all those applications comes under application layer, which is used for communicating, for communication purpose. Let's say Outlook, let's say WhatsApp, let's say Teams, everything is comes under application layer. Okay, this is all about then OSI layer. Let's go back to the that diagram which I have showing. Yeah. So if you see here, we have, just hold on. Mm, Yeah. If you see here, we have 7 layers as we described. This again, I repeat, this layer is where the application works. All the application which we work under, the application. Presentation is kind of where we convert those no layer into a format where it can be sent, it can be no sent to the designated device. Sessions kinds of create and session to know communicate between both the devices. So there is an example like even API sock or WinSock, or maybe I know we can API gateways to communicate between your application and application and your designated services. So all those are comes under session layer. Transport layer is kind of know where the data is transferred from one end to other end, and make sure that data is transferred using the protocol TCP or UDP. Now, and talking about protocol is set of rules, uh, how a communication should happen. That is what we call it as protocol. So TCPs and protocol, IP addresses and protocol. So there are a lot of various protocols we will discuss in this course. So in transport layer, we are talking about TCP. In network layer, we have IP address and routing and all those things comes under network layer. And data link layer, where we talk about MAC address and switches and all those, where it's a, a basic layer where your distribution, first level of distribution of data initiates. And the last one is like where you have cables, connectors, and all those things comes. Okay, so this is how. And if you see this layer, starting from your application to the physical layer, and you can just reverse the entire communication back uh, to the secondary device. Let's say talk about maybe google.com, and then this is the 7 layers which it has to go through, and it'll reach the designated network. Any doubt in OSI layers, please, or any layer which you didn't understand or you need more clarity? I'll try to explain it. Am I audible? You can write your queries on the chat box, and if you have no doubts, that also I would request you to just communicate back at least one. Yeah, Desmond.
Yeah, so when you say the session, so is it like I saw you put SSH like when you say is it like I know SSH is kind of a getting into a network, my kind of access into a particular network. Is that what you mean?
So session is kind of uh, uh, okay. I will explain in a way. A session is like a conversation, Desmond. Like when usually when we chat when we chat in Teams or any WhatsApp, there is a conversation where where we start talking, and there's a place where we end, and that entire communication is what we call it as a conversation, right? So that conversation, you can take it as in session, because each conversation is set of communication between you and me, and that is one set. and that set is what call it as in session. There is a timeline for a session to be there. For example, there is a device which needs to communicate to a B device. You can say it's kind of a tunnel, or it's kind of an uh, uh, as I discuss, how can you explain a real time? Let me see.
It's like it's timed. Like okay,
Yeah,
this is
it's a
this is the
time
session.
where, yeah, so where there's a time where the communication happens. But again, that entire communication is what we call it as an session in between, that entire transaction has place. Like if I you and if me and you talk, and whatever the conversation we have now, unless your doubt is cleared, and if your doubt is cleared, then from the point you queried about the doubt, and the till the point you have got clarified your doubt, that time is what we call it as in session.
Okay.
Okay, great. Anyone else has any doubt? These are very basic concepts, so I would request you to please have any doubts that should be clarified here. I know many of you have gone through these, and you are aware of it, but still to keep everyone on same page, that will be great. Okay, one more. Uh, who else has raised a hand? Yeah, Manmohan. Yeah, Madan. Yeah, Madan Mohan. Yeah, tell me. Madan Mohan, you can talk. Hello.
A wants to communicate with the server B. Hello.
Yeah, Madan Mohan, please.
Yeah, yeah. Server A wants to communicate with the server B. We need to you need to register that IP address, MAC address, and port number in the router or switch level. How it will communicate? How it will know that A and server B.
Okay,
Server A.
that's yeah. So there is something. There are two different devices, Madan.
Okay.
You can just lower your hand. I'll explain.
Mhm.
I'll show you some diagram. That would be easy. Just hold on. I'll just show you an image.
Okay.
That will be easy for you to understand. Okay. Hope you can see this image.
Yes. Yes.
Okay. So when are two devices, probably it may be a server, or it may be a desktop, when it is connected to a switch. So initially, when the switch gets powered on, it doesn't know what are the devices it's connected to. So it kinds of create a first broadcast, and then it know a broadcast. After the first broadcast, the switch starts collecting the information from each computer. How that happens is, for example, um, a device which wants to communicate to, for let's say, host A wants to communicate to host B. The host A becomes source and host B becomes destination. Now, first, when a
Okay.
request comes to switch, it opens the packet, and then it just amends the source MAC address and the port to which port it has connected, right? In the similar way, once the destinated device communicates back to the host stating that the data is received, then in that case the destinated device becomes source. So that particular MAC address is again populated in the this particular table. This table is called forwarding table, where each switch, all the switches maintain this forwarding table with the MAC address. Like all the devices which are connected to this MAC address, to this particular switch, will have all the MAC addresses and the designated ports to which they are connected, so that in when next communication happens, it will be easy for switch to identify from which port the source is and to which port it has to destinate it. So that's how switch works. Okay. When talk
Okay.
about routers, routers work in a different way. Routers connects two or more different networks, right? So router work in a network layer. So there we have something called as routing table. So what there here we mention MAC address, there we mention IP address or subnets, where which subnet has to give access, what is the next hop to. For example, I have a hop. Let's say that also I have. I think just give me a second. Mm, Let me see. I can give you a depiction of that also. Yeah, that's super. Okay, so yeah. Okay, now I'll keep this side by side, both. Okay. Now, if you see here, this comes under layer 2 switch, and we are dealing with MAC address. So switch creates a forwarding table which has all the MAC address and all the ports, designated ports, and that's how communication happens. But when you talk about routers, routers work in routers work in IP address. So if you see here, these are two or three routers which are connected. Now here we call something called as routing table. So there we call it as a forwarding table. Here we call it as a routing table. So routing table symbol how the data has to route from one network to another network. So here we mention the destination network. For example, this is the port from which the initiation of the request starts. So what would be the next hop and what would be the destination? So we mention all those addresses, and that's how we route. There are a lot of routing protocols we will see in depth, but this is a basic. I just want to make you understand that routers work at IP level and switches work at MAC address. And there are switches which are layer 3 switches. Those have the capability of routers also. But basically, when we have day-to-day switches which you see in our offices are layer 2 and they work at MAC address server. Hope I have cleared your doubt, Madan. Any
Yes,
doubt?
yes, I got it.
Okay,
Yeah,
thank you.
no, no, I got
Okay,
it.
okay,
Clear now. Yeah.
great, great, great. Lower your hand. Thank you.
Thank you, thank
Anyone
you.
else has doubt? Okay, great, great. So let's move ahead. So we have seen OSI layer. Now we will see an interesting topic: how an internet works and what is a DNS. Um, so we humans are very good at no uh, English. We are very good at pictures. If you see, there are a lot of pictures in my presentations. I usually believe learning by pictures because human has a tendency to remember those are visuals rather than numbers or text. When talking about DNS, so we are good at English. We are not. If I say you remember the IP address of google.com, I remember the IP address of tons of website which you see, remember every site's IP address. It is not possible because we are not good at numbers. We can't remember all those numbers, all those addresses. It is not at all possible. So there is a way to there's a way there's an easy way to remember its names. So what a DNS server does is, see, these all websites which are hosted in internet, they are at the end of the day a server which has an IP address, right? And to access that particular web server or website, we should have a name, and that name, what we call it as a domain name. Okay, so let's say google.com is a domain name, and that in turn resolves to an IP address where that particular google.com web page is hosted, that server. Okay, now DNS server does that name resolution. It converts a name into IP address, and it also does the reverse way. So that is what a key component of our internet access. See, when if you see this diagram here, a user is trying to access google.com. So he opens the browser, enters the URL, and press enter. The moment you press enter, it the first thing is it goes to the service provider's DNS server and checks whether there is an IP address is mentioned with respective domain name. If it is there, then of course it will know directly go to google.com, and then it will resolve. If it doesn't have, then it will go step by step. So first thing is, uh, uh, I know uh, where the .com DNS server is there. I will try to get information from .com. So first it will go to .com, and it will get the detail of the google.com address. Then it will reach google.com, and then from there it will get the DNS IP address of the web server, and then from that web server it reaches to the eventually to that designated web server, and the page which is requested, if you are authorized, that page is again no same with from the same path. You get the access to that particular page. Now the name resolution here is very key in internet, and DNS plays a very important role in a network also. We'll see in detail, but this is an a glimpse how internet works, and now how DNS works in internet. Now next slide is bit complicated. This is how we work in usually we talk about no in our home. So let's say the top, this one is your home. I'm trying to access some site from my home. So it eventually the communication, the request goes out of my router, and it reaches the service provider, and then from service provider eventually no has an external DNS server from the DNS server, and through various routers it reaches the destinated network, and then from that destination network it reaches the web server. So this is kind of a office where we have uh, DNS server, SQL server, or a lot of servers are there, and like any website, let's say google.com or maybe any yahoo.com, whatever may be, the destinated is an office, or is in data center, or it's some network where I can communicate, where we have a network infrastructure, where we have switches, where we have servers, and all those global offices are connected. That's why I told all those different networks are interconnected. That's kind of a mesh network where this huge internet works. So if you talk about internet, uh, if you now onwards, if you think about any URL like google.com or any like discovery.com or whatever, the request at the end of at the end of the day, it reaches to an on-premises data center, or a cloud-based data center, and the request comes from there. There all we have physical servers, applications, switches, routers, everything is deployed as what we have in our offices. And you can say all those offices across the globe are connected with each other to form internet, and that's what we call it as internet. And something called as intranet is something, uh, 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 a network within our organization. Like I have an office global presence, having I have global presence on across all the continents, but I'm in a closed network. So that is called intranet. Even though I have different locations that I have connected, all those global locations are connected. Then I call it as intranet, which is my private WAN. If I talk about internet, then those are public, which are publicly available. Those are called as internet. So hope I have cleared you about intranet and internet. And tomorrow we will look into a bit of IP addressing and subnet. And if you have any queries, I can take some 2 or 3 minutes to address your queries, and then we can wind up the session for today. Any doubt? Okay. Thank you. Thanks everyone. Thanks for your time. Have a great day. Yes, yes. Who's this? Chetan. Yes, Chetan.
Audible, sir?
Yeah, you have just raised your hand, so I just.
Hello,
Yeah,
am I
Chetan.
audible?
Yes, yes, yes.
Okay, sir. My question is, what is the pattern we are going to be learn for the next couple of days? I mean, the practical sessions, and then this is all the theoretical part. Last 2 day I attend that. This is doing a theoretical part, which is I think I already been in the YouTube. I go and I check this. All these things are the similar things are be there. So,
Mhm.
what is the pattern we are going to be next couple of days? Apart
Okay,
from we cannot see in the other sources.
okay. So it's not. See, first of all, Chetan, like as I told earlier, you might aware of all these things, and then these things are available in internet. But when we talk about any course, there should be a start, and I want to make sure that everyone is on same page. That's the reason we are covering these basics for 2 days. That's one thing.
Mhm.
We are going to use simulators across our courses to take practicals. So because now it is not possible everyone to purchase routers and switches, right? So
Yeah.
right, so we have a Cisco packet tracer to use that as in simulating no simulation for all your routers, switches, firewalls, and PCs and whatnot. All those practicals will be done in Cisco packet tracer via Cisco packet tracer. And how the classes will be done is like there will be a topic which every day I will take, and then there is a corresponding practical associated with that particular topic. Let's say if we talk about how to configure a switch, so I will be taking all those, what is switching, what are the protocols used, how the switching is done. At the same time, how to configure a switch. So that is done in the lab session in the simulator. Okay, so every day the session will go in the similar way. And if you have any queries, we will be giving you assignments on probably on day-to-day basis or weekly basis. So where you can do those live assignments, how to connect multiple routers, how to connect multiple networks, VLANs, and all those things. And the thing, once that is your, for example, I have covered a topic, I have given you a demo of lab, and then I have given you assignment to do that on the same day or probably after a couple of days. Then you will be able to know, remember that entire concept, what we have taught. And my assignments are differential. Like for example, I take a topic A today, and today next day take a topic B. Let's say today I taken a topic about switches, and next day I take a topic about routers. So the assignment which I will give you will have both routers and switches. So how to connect those devices, how those communications happens. So it will be kind of, you will be learning kind of an solutioning pattern. And we also give you some real time no projects or real time solutioning projects where you can design network, you can configure all those routers, switches, and firewalls, so that you get confidence each module by module. We will continue that pattern till end of this session. So that's how you will learn the in real life how those devices, how it is configured, how we are going to provide solution also when you when we design a network. So what are the things which we have to know, take notice. So all those things are covered. As these are first 2 days, sorry, we have repeated sessions for you, but our rest of the sessions will have, we are going to follow the same pattern.
Oh, okay. Thank you, sir. Yeah.
Yeah. So
I thought it would be a
I
long
know many of you.
session.
Yeah, I
Yeah, that's
know.
why I asked a question.
Yeah, I know many of you have this doubt, but uh, see, when even I started learning um, way long back, I also remember. I know all these things, but still I learned it because sometimes there are certain things, a small thing would be miss out. I'm not sure. You might know everything, and I know these things are available in internet. But when we create the entire change, it will be chain. When you create the entire chain, it makes sense. Yeah, Gopinath, please. Let me unmute. Yes, Gopinath, you can talk.
Hello. Yeah, am I audible?
Yes, Gopinath.
Yeah, good morning. So
Good
you
one.
said that we are going to use simulators to run the practicals. So the practicals will be done parallelly by the participants with the host, or it is once it is done, we should practice ourselves.
No, no, these softwares will be deployed in your laptop, and you can there are sessions where you have to do parallelly. There are sessions where I'll give you assignments and you have to do it post the session. So it
Okay.
works both way. Yes.
Can you please share that link, the simulators?
Yeah, I'll do that. What I will do is I will upload that link in the LMS, and you can download it. Everyone can download it from that link. Okay.
Yeah, fine.
Is
Thank
is
you.
that okay? Yeah, yeah, sure.
Thank
Thank you.
you.
Thank you. Anyone else has any doubts? Okay. Thanks everyone for your time. And have a great day. I'll see you tomorrow. Bye bye.
Thank you, sir.